is a database. In simple terms, if someone asks you what is Power Pivot, it's one database which is used to prepare a OLAP model, or which is used to prepare a OLAP model, also call it as data set. Power Pivot is a database. We use the data set. Power Pivot is a database. We use the database to prepare an OLAP model or to prepare a data set, guys. To prepare a data set. Okay. Now, so we are telling it's a database. We know the databases like SQL Server, a Power Pivot database. So how Oracle is a database, how SQL Server is a database, even Power Pivot is also a database, guys. So what is the purpose of database? Database is used to store the data in the form of tables. Database is used to store the data in the form of what? Database is used to store the data in the form of tables. It is helpful to store the data in the form of tables. So here in the SQL Server also, it's a data in the form of tables. Oracle also database where we used to store the data in the form of tables. My Power Pivot is also a database where we will store the data in the form of tables here also. How SQL Server and Oracle will store the data in the form of tables, Power Pivot also will store the data in the form of tables. But what is the difference between this Oracle SQL Server and Power Pivot is, this Oracle SQL Server or traditional databases or relational databases. Traditional or relational. It is not a relational database, it's a in-memory database. The most important thing we need to understand is, it's not a general database like SQL Server and Oracle. It is not a relational database. It's a in-memory database. There are two types of databases in the market. One is relational databases. We also call them as relational databases. We also call them as traditional databases. And the second one we have is in-memory databases. In-memory databases. These are the types of databases you have, guys. Examples for relational databases are Oracle, SQL Server, etc. And examples for in-memory databases. Power Pivot, etc. and so on. Right? So what makes the difference is between them? When you create a report on relational database, when you create any report on relational database, when you share that report with the client, when client open the report, it takes time to load the data into the report. I created a report on huge volumes of data and I shared that report with my client. When my client opened that report, might be to see the data in the report, it might take 60 seconds of time. 60 seconds of time. Every time when he opened the report, he need to wait for 60 seconds of time to see the data. The same data, what is there in the SQL Server, I have in the Power Pivot. Same data, there is no difference. And I get the same report. And I shared that report with my client. When I share that report with my client, when my client opened that report, he can see the data within 5 seconds of time. 5 seconds of time. Here, same data, same report, taking 60 seconds of time. Same data, same report, around within 5 seconds of time it will show the data. So advantage with Power Pivot is performance. When you create the report on Power Pivot, it is much faster. Or when you create the report on in-memory databases, the report is much faster when compared to relational databases. You can write one point here. When we create a report on, when we create a report on in-memory database, it is much faster. It is much faster than relational database case. When you create a report on in-memory database, it is much faster than this relational database or traditional databases. Yes, there is no doubt in it. So how it is faster is, let me explain. So Microsoft designed this Power Pivot purely for reporting purpose, guys. Purely for reporting purpose. How it is faster is, when you access the data from a relational database, it will give the data from hard disk, guys. Hard disk, I already explained. So when you access the data from relational database, it will give the data from hard disk. When you access the data from Power Pivot, in-memory database, it will always process the data from RAM. In-memory databases will process the data from RAM. You can write this point. Relational databases will process the data from hard disk. Relational databases will process the data from hard disk. In-memory database will process the data from RAM, guys. In-memory database will process the data from RAM. Which one is faster means, there is no doubt. RAM is tens of times faster than hard disk. Tens of times, not 1 or 2 times. When you take the data from hard disk, when you take the data from RAM, it is tens of times faster. Tens of times faster. Fine. This is the first reason, guys. Not only this, so the architecture of in-memory data, the architecture of relational databases, the way they store the data is completely different. The way they process the data is different. So the way we store the data in Power Pivot is different. The way it processes the data is different, guys. The architecture of relational database is completely different. The architecture of in-memory database is completely different. So architecture means the way they store the data internally, the way they process the data is completely different. The way they store the data internally is different. The way they process the data is completely different. Completely different. Let's understand. Basically, in the relational databases, the data will be stored in the row format. It will be stored in which format, guys? Row format. Row format. What is that row format? You will understand. So in relational databases, data will be stored in the row format. Let me write here. In relational or traditional databases, data will be stored in row format. But when it comes to in-memory database, in in-memory databases, data will be stored in the columnar format. What is this row format and columnar format? Let's understand. Fine. Let's understand. Let me open one document here. I'll give simple example. Or material. So I said that so we have two types of databases, like in-memory databases and relational databases. In relational databases, data will be stored in the row format. In the relational databases, data will be stored in the row format. What row format means? Let's assume I have one table like this. I have employee name. I have job, salary, and department number. I have 4 columns here: employee name, job, salary, and department number. I'm trying to store this table in relational database like Oracle and SQL Server. In Oracle and SQL Server, when you try to load this table, when you try to store this table, how it will store is in the row format. It will take first row, it will store in the first block, guys. And it will take second row, it will store second row then. And it will take third row, it will store third row. And it will take fourth row, and it will store fourth row. And it will take fifth row, it will store fifth row. And it will take sixth row, finally, it will store sixth row. Like this, it will take each row and it will store in the row format. Row format. Okay. But when it comes to columnar database, in-memory database, the data will be stored in the columnar format. The data will be stored in the columnar format. Look at this, in-memory databases, the data will be stored in the columnar format. Take the same table, so which contains 4 columns: employee name, job, salary, department number. When I try to store this table in Power Pivot, how it will store? I said that it will store in the columnar format. So it will take first in the block 1. Then it will take second column data, it will store in the second block. Then it will take third column data, it will store it. Then it will take fourth column data, it will store it. It will store it. Like this in the columnar format, it will store. So when it stores the data in the columnar format, we have advantages, guys. We have advantages. What advantages we have is we can compress the data. So the first, there are advantages with columnar format. Columnar format is first advantage with columnar format is the data will be highly compressed in Power Pivot. The data will be highly compressed. Compressed in-memory databases. In-memory databases. So when we store the data in the columnar format, the data will be highly compressed. In the in-memory data, data will be highly compressed. So when you are storing some data in the SQL Server, let's take an example. I am storing some data in the SQL Server. It is occupying 100 GB space. 100 GB space. When I store the same data in the Power Pivot, it will just occupy 10 GB space. So that means data, we have a capability to compress the data and reduce the data size. Compressing the data means it will reduce the data size. So how much space you are saving? Almost 90 GB space you are saving. In Power Pivot, data will be compressed till 1/10 of source data. 1/10 of source data. 1/10 of source data. Data will be highly compressed. Not almost 1/10, it will compressed. Highly compressed. When SQL Server contains 100 GB data, when you load it, it will come to 100 GB data. When you load it to Power Pivot, it just comes to 10 GB, guys. Approximately 10 GB. So if someone asks you in the interview, till what extent data, it is one of the important questions. To what extent data will be compressed in the Power Pivot? 1/10 of source data. It will compress the data 1/10 of source data. Right. Now, how it is not able to compress in relational databases? Why we are able to compress in in-memory databases? Here it is not able to compress in relational databases, but in the in-memory databases it can compress. Why? Why means I said that in a block we'll store raw data here. When you store one row data, the data might contain text values like this. The data may contains number values. You have different data types data in a block. When you have different data types data in a block, it is not possible to run the compression algorithms. We have compression algorithms in the software field. So in the software field, when you have different data type data in a block, it is not possible to run that compression algorithms. Obviously, when you store any one row data, that row contains different data type data. When you store different data type data, it is not possible to run the compression algorithms. So that is the reason it is occupying more space when you store the data. But when it comes to columnar database or in-memory database, you can run that compression algorithm, guys. You can run that compression algorithm. How can you run that compression algorithm? Is in the in-memory database, we'll store the data in the columnar format. When you store the data in the columnar format, a block will contain same data type data. So when I have same data type data, you can run text compression algorithms. So we have algorithms, we can run it. So look at this. When I try to store columnar data, this column data, and then this column data, and then finally this column data, I can go and run compression algorithms now. So what compression algorithm will do is, just give me an example. Let me give an example. What compression algorithm will do is, so let's take this block. In the block, it will run compression algorithm, guys. What that compression algorithm will do is, first time when clerk is coming, for that clerk, it will give an ID like 1 or something here. It will give one ID. So into the block, when clerk is coming, it will give an ID called 1. And later on, wherever clerk is coming, it will not store complete clerk, it will store with 1. Wherever clerk is coming again, it will not store complete clerk, it will store with 1. Whenever clerk is coming, it will not store complete clerk, it will store with 1. So instead of storing complete clerk, if you store 1, it will take less space. Same way, for the first time analyst is coming, it will give an ID called 2. From the second time analyst is coming, it will not store complete analyst, it will store with 2. So instead of storing complete analyst, if it stores with 2, how much space you will save? So this is how, so there will be some mechanism. There will be some mechanism in the compression algorithms. That mechanism will help us to reduce the space. And you can run only the compression algorithms when a block contains same data type data. When you store the data in the row format, there is no chance of running the compression algorithms. When you store the data in the columnar format, each column wise, there is a possibility to run the compression algorithms. There is a possibility to reduce the size. So that is what here. The data size is coming to 1/10 of source data. Okay. There is one more advantage, guys. Not only this, there is one more advantage. When you perform any aggregate calculation on SQL Server database, so let's take an example. I have one sales table in my SQL Server. That sales table contains 100 million records. 100 million sales transactions are there. From 100 million sales transactions, I want sum of sales. From 100 million sales transactions, I want sum of sales. Let's take an example. To perform this aggregate calculation here, I approximately take that it is taking 10 seconds of time. 10 seconds of time. But the same sales table is here. The same 100 million records are here. When I perform sum of sales here, it can just show the data within 2 seconds or 3 seconds of time. So here it is taking 10 seconds of time. Here it is taking 2 seconds of time. Sum of sales means an aggregate calculation. When you perform any aggregate calculations on Power Pivot, it is much faster than this relational databases. So how it is faster? So reporting is all about showing aggregate data. When you have the data, when my client is asking to create reports, they will always ask you to show aggregate data, like show me count of orders, or else show me count of customers. Count is an aggregation. Show me count of orders. Again, count is an aggregation. Count of orders. Show me sum of sales. Sum is an aggregation again. Show me sum of profits. Aggregation again, right? Aggregation. So whenever we need to perform any aggregate calculations on Power Pivot, it is much faster. It is much faster. How it is faster? Let me explain, guys. How it is faster is, so look at this. In relational databases, the data will be stored in the row format. When the data is storing in the row format, each row wise. Here, when you perform some aggregations, it takes time. Let's take an example. I store this table's data in row database like SQL Server and Oracle. My client is asking to show sum of sales. To get sum of sales, sum of salaries. So this table you stored here. On top of this, I need to get sum of salaries we are paying. There is a salary column for each employee. How much is the salary we are paying? We have it. My client is asking to create one visual. Show me how much sum of salaries we are getting. So you need to collect all the salaries here. So in the first block, I'm storing first employee salary. I need to collect this salary first. In the second block, I need to collect this salary. From the third block, I need to collect this salary. I need to collect this salary. And even from the fourth block, I need to go and collect the salary here. Once after collecting the salaries from different places, I need to sum them. Going to different places, collecting them and doing an operation will take time. So that is the relational databases. It takes time. It takes some time. But the same sum of salary I want here. The same table I'm storing in in-memory databases in columnar format. And on top of this, I need to calculate sum of salaries I'm paying for all the employees. This time when I want to show sum of salaries, I don't want to go to block 1, I don't want to go to block 2, or I don't want to go to different places. All the salaries are there in one place. I don't want to go and collect from here and there. Every salary is there in one place. I can take all of them, I can submit. Here you need to go to different places, you need to collect them, and you need to do it. It takes time. When you take from one place, when you do it, it will take less time. So that is what I guess. When you perform, the second advantage is when you perform aggregate calculations on in-memory databases, they are much faster. In-memory databases, they are much faster. Relational databases. Yes, guys. Right. So when you perform any aggregate calculations on in-memory databases, they are much faster than relational databases. Purely Microsoft designed this Power Pivot for what purpose, guys? Reporting purpose. So when you at the end, when you create the report on relational in-memory databases, it will show the data in the reports within less time. So on the whole, we can call Power Pivot as in-memory columnar database. Some people will call Power BI as just a database. Some people will call Power BI as in-memory database. Some people will call it as, if you want to explain in a detailed way, even if you call this as a database, when people call Power Pivot as a database, yes, they are correct. It's a database. Even this statement is correct. Some people will tell that Power Pivot is in-memory database. Yes, even this is correct. If you want to tell in a detailed way, Power Pivot is in-memory columnar database. Some people will call Power Pivot as in-memory columnar database. So why columnar? It will store the data in the columnar format. In-memory databases will store the data in the columnar format. Fine, guys. So in interview, they'll ask some questions. So when you take the data from any source, when you extract the data, when you transform the data, when you load the data in Power Pivot, the data will be compressed to 1/10 of source data. Which software is working to compress the data and stores the data in its own format? In Power Pivot internally, we have one software with the name Wetipack Engine. So let me open the course content, guys. Power BI material. So in Power Pivot, we have one software with the name Vertipack or XVelocity in-memory engine. So in interviews, they'll ask, what is Vertipack software, or what is XVelocity in-memory analytics engine, XVelocity in-memory software. So in interview, they'll ask a question, what is Vertipack software? What is Vertipack software? What is XVelocity in-memory software? What is XVelocity in-memory software? What is XVelocity in-memory software? Right, look at this. XVelocity software. So when you try to load the data into the Power Pivot from Power Query, when I try to load the data into the Power Query to Power Pivot, so internally in Power Pivot, we have a software with the name Vertipack engine. Vertipack. That is the software which will take care to compress the data and to store the data in the own software. So older days, the name of the software is Vertipack software. Now they renamed the Vertipack to XVelocity in memory, guys. So both are same. Both are same. So before few years back, Microsoft given the name for that software is Vertipack software, and now they changed this name from Vertipack to XVelocity in memory. Even though when they change the name to XVelocity, in some interviews they will ask with this name. In some interviews they will ask with this name. Both are same. You need to tell this is old name and this is new name. So old name is what this? Vertipack software. And new name is what? XVelocity in memory. New name is XVelocity in memory. What they will do, guys? It is the software which is there internally in Power Pivot. It is the software which is there internally in Power Pivot. Let me write here. It's a software which is there internally in Power Pivot, which is responsible to compress the data. So what it will do is, okay, it is the software which is there in Power Pivot. When you load the data from Power Query to Power Pivot, when we load the data from Power Query to Power Pivot, from Power Query to Power Pivot, this software will come into the picture. This software will come into the picture, guys. Whenever you are trying to load the data from Power Query to Power Pivot, this software will compress the data and stores the data in its own format. So you can just write compress the data. Till here it is enough, right? It's a software which is internally in Power Pivot. So in Power Pivot, internally we have that software, Vertipack software or XVelocity in memory software. And when we load the data from Power Query to, what it will do? Okay, it is there in Power Pivot. What it will do? When we load the data from Power Query to Power Pivot, so this software will come into the picture. That software will come and compress the data and try to store the data in its own format, guys. So this is all about the internal things about Power Pivot. Whatever I discussed here, nothing to do as a developer. So you will not do anything here, but we just try to understand how powerful Power Pivot is when it comes to reporting. Even though when we are not going to do anything as a developer, here you will get two questions. Till what extent the data will be compressed in Power Pivot is one question. And the second question is, in Power Pivot, on which format the data will be stored, columnar format. And third question you will get is, what is Vertipack software or XVelocity in-memory software? So if you want to answer, you need to have a clear idea what it will do, right guys? Now I'll explain as a developer what we will do in the Power Pivot. We'll discuss now. As a developer, what we will do in Power Pivot, we'll discuss now. As a developer, we will perform two activities in Power Pivot. Two activities in Power Pivot, guys. First activity is data modeling. As a Power BI developer, we'll perform two activities in Power Pivot. One is data modeling, and second one is enhancing the data model. Enhancing the data model. Let's talk about this, guys. What is data modeling and what is enhancing the data model? Let's discuss. First, I'll start with data modeling. Data modeling will take around 5 hours of time, and enhancing the data model will take around 10 hours of time. So enhancing the data model is the place where DAX will come into the picture. First, let's start with data modeling. So we will extensively discuss about data modeling concepts here. So important, guys. From the data modeling side also, you'll get a lot of questions in the interview. Lot of questions you will get in the interview from the data modeling side also. Let's understand first. We know what is data modeling means. We know the definition of data modeling, right? Establishing the relationship between the tables, we call it as data modeling. Establishing the relationship between the tables. Between the tables, we call as data modeling, guys. So the process of establishing the relationship between the tables, we call it as data modeling. So first thing you need to do is, once you load the tables, let me close this document. Once you load the tables from Power Query to Power Pivot, you need to, so once you load the tables, you need to go and establish the relationship between the tables. The first thing in Power Pivot, when you join in the company, you extracted the data, you transform the data, and you load the data. As soon as you load the data into the Power Pivot, you just want to go and give the relationships here. Relationship between these tables. That is what we need to do. So the process of establishing these relationships, we call it as what? Data modeling. Okay. So why we need to do the data modeling? We already discussed, right? So why we need to do the data modeling? Why we need to do data modeling? Once you load the tables, why we need to do the data modeling we discussed? The same question they can even ask like this. What is the need of establishing the relationship between the tables? Why we need to establish the relationship between the tables? Why we need to establish the relationship between the tables? Both questions are same. So I open Power BI here. Now I'll bring some tables into the Power Pivot. So two ways you have it. You can even bring it using get data, or else you can go to transform data. You can go to Power Query. In the Power Query, you can click on new source. When you click on new source, you can bring the tables. Click on Excel. I'll bring some tables from EMP, DEP to Excel. Click on open. Click on open. EMP table, DEP table, and managers table. Press OK. I want to bring some more tables into the Power Query. Click on new source. Click on Excel. Sample Superstore. This time from another Excel file, Sample Superstore. Click on open. Select returns table, people's table, and orders table. Press OK. Press OK. And I want to bring some more tables from database. Click on new source. Click on SQL Server and provide the server name. Provide the server name. And database name is optional here. Press OK. It will open the server. and it will show the list of database you have. Expand the database from where you need to bring the tables. Select the tables, click on OK. Once you bring the tables to Power Query, if required, you can transform the data. You can go to any table and you can transform the data. I want to move the first row to header, click on use first row as header. In the people's table also, I want to move the first row to header, click on use first row as header. So like this, you can go to any table here. With the help of the options you have, GUI options you have, you can transform the data. Once you are done with transforming the data in the all tables, you can load this data. Click on close and apply. As soon as you click on close and apply, it will try to load the data into the Power Pivot. So when you are loading the data into the Power Pivot, in Power Pivot software, this Xvelocity software will come into the picture. As soon as you load the tables into the Power Pivot, Xvelocity software will take care to compress the data in the Power Pivot software, guys. Yes, that will happen. So that will happen internally. Click on close and apply. As soon as I click on close and apply, now Xvelocity software will come into the picture. It will try to compress this data and it will try to store the data in the compressed format. Right, I loaded the tables and I have all the tables in the Power Pivot software. Totally, I loaded 9 tables. I'm able to see 9 tables here. All the 9 tables here. Right. Now, when you load the tables, Power BI have the intelligence to establish the relationship between them, guys. Fine. You loaded the tables, but if you see, so what is the limit of Power Pivot? Power Pivot software, how much data it will hold? So this is not the right place to explain it. So in Power BI service, we'll discuss. So there are 2 types of licenses in Power BI service. One is Pro license. Second one is Premium license. Premium license. When you have Pro license, the data set size is maximum 1 GB. So when you have Pro license, you can build a data set with 1 GB. Only 1 GB data set it will support for Pro license. That means you can load 10 GB of data. When you load 10 GB of data, it will come to 1 GB and you can publish it here. And if you have a premium license, so in the premium license, the data set size is 10 GB. The data set size is 10 GB. That means you can load the 100 GB data from the source and it will become 10 GB and you can publish it to the premium workspace. There are 2 types of licenses. So the licenses part we will discuss in Power BI service. One is Pro license. Second one is Premium license. Pro license can support a data set with 1 GB. Like this, you can create a lot of different data sets. With 1 GB, you can create n number of data sets. When it comes to Premium license, the data set size is 10 GB. 10 GB. So here I'll discuss it. For now, max a data set size is how much, guys? 10 GB. That means how much data you can load? 100 GB data I can load in one data set. Like that, I can create multiple data sets. Fine. So now when you load the tables into the Power Pivot, it will automatically do the data modeling work. You'll see you got this relationship here. You got the relationship here. So look at this, you got the relationship here. When you load the tables into the Power Pivot, it will do the data modeling automatically, guys. Power Pivot have the intelligence to. Older days, when you load the tables, you will not get these relationships. In the older days. But these days, when you load the tables, majority of the data modeling work will be done by the tools itself, the softwares itself. Same way, our Power BI also will do the majority of data modeling work. Majority of data modeling work will be done by Power Pivot itself. When you load the data into the Power Pivot, majority of the data modeling work will be done by Power Pivot itself. How majority of the data modeling work is done by Power BI or Power Pivot? I answered these two questions. These are the two questions. I answered this in the introduction classes. Let me quickly explain it. So in introduction classes, in an extensive way, I discussed what is this and what is this. Let me give at a high level. So why we need to have the relationship is, why we need to have the relationship between the tables is, so whenever we need to create one visual on more than one tables, I want to create a visual on employee table, I want to create a visual on DEPT table. Whenever I need to create the visual on more than one tables, must and should you need to have the relationship, guys. Must and should you need to have the relationship. So just I'm trying to create one visual here, and in that visual I need to show some data from EMP table, I need to show some data from DEPT table, I need to show some data from EMP table, I need to show some data from DEPT table. In the real time, companies will never store all the data in one table. Few data will be stored in one table, few other data will be stored in another table, few other data will be stored in another table, guys. They will store the data in the multiple different tables. Now, so they might ask you to create the visuals by taking the columns from different tables. My client is asking to show employee name, and my client is asking to show, along with the employee name, what is the designation of that employee. Job, when you drag the job, you can see Adams is a clerk, and each employee, what is the job you are able to see, and client is asking to show what is the salaries we are paying, and client is asking to show in which department number they are working. Till here I'm comfortable, guys. So I'm taking the columns from only one table, I'm able to show it. Along with this, client is expecting to see what is the department name. The Adams is working in which department name, and Adams is working in which location. I want to show department name column and location column here. 20th department employees, in which department name they are working, in which location they are working. So unfortunately in EMP table, I don't have department name column and location column. Where they are storing department name column and location column, department name and location, they are storing in DEPT table. So 20th department employees, they belongs to research and Dallas. 10th department employees, they belongs to accounting and New York. 30th department employees, they belongs to sales and Chicago. Right? Look at this. I want to drag the columns from another table, DEPT table, department name and location. Now I'll go and delete this relationship now, and we'll see what is the importance of this relationship. If you want to delete this relationship, right click on it, click on delete. Click on delete. These two are independent tables now. These two are independent tables now. Now I want to show department name and I want to show location here. When I drag them to the visual, so the visual is not showing the data. So when you have only columns from EMP, it is comfortably showing. When you add the columns from DEPT, it is not showing. When you remove these two columns, it will show again. So when I drag department name, when I drag location, it is not showing. So if you click on see details, what the message is, you're trying to drag the columns from two different tables, but there is no relationship between the tables. That is the reason I'm not able to show it. Yes. Okay. So if you want to see the data in this visual, you need to go and give the relationship here. To establish the relationship, we need to have a common column here. I have a common column department number and department number. Based on this department number, I can go and establish the relationship. Select the department number, drag and drop on department number. We'll discuss about data modeling from here. For 5 hours of time, you'll get everything. Just concentrate. So as soon as you got the relationship here, you are able to see the data. 20th department employees, they belongs to research and Dallas location. 10th department employees, they belongs to accounting, New York location. 30th department employees, they belongs to sales, Chicago. You are able to show comfortably now. Whenever we need to create a visual using more than one tables, you need to have the relationship. And along with this, client is expecting to see manager name. For Adams, who is the manager? For Ellen, who is the manager name? For James, who is the manager I need to show? When I want to show manager name, the manager name is available in manager's table. Manager name is available in manager's table. I want to drag the column from another table here. Now I'll go and delete this relationship for now. Right click on it, delete. I'm deleting this relationship. I'm not having any relationship here. But in this visual, client is expecting to see one more column from another table, manager's table. He is expecting to see manager name. When I drag the manager name, it is not showing the data. What is the problem again? There is no relationship with this manager table. So if you want to see the data in this visual, what you need to do? You need to have the relationship between them. So go and drag the manager number and manager number. Common column is manager number here. I'll go and establish it. As soon as you establish it, you got the manager name. So like this, sometimes we need to create the visual on 2 tables. Sometimes we need to create the visual on 3 tables. So if you want to even create the visual on 5 tables, if they are related with each other, you can show it. We can create the visual on 3 tables, 4 tables, 5 tables also. But they should be related. They should be related. We understand why we need to do the data modeling. Whenever we need to create the visuals using more than 1 tables, like 2 tables, 3 tables, 4 tables, 5 tables, they should be related with each other. How to give that relationships, we'll see extensively. Now, once after this, the second one is majority of the data modeling work will be done by Power BI or Power Pivot itself. When you load the tables, majority of the data modeling work is doing by Power Pivot. How it is doing is, I said that there is 2 settings here: file menu, options and settings, options. There are 2 settings available here. So when you go to here, you will find current file. In the current file, you'll see data load. In introduction classes, I explain it. Please go through the introduction classes if you want to see the explanation, detailed explanation. Now, you have in the current file data load. In the data load, you have relationships. There are 2 checkboxes selected. These 2 checkboxes are working to get the relationships. Yes. So when you bring the tables from SQL Server, you got the relationships automatically. When you bring the tables from SQL Server, this customers data table, sales data table, product data table, I bought it from SQL Server. When you bring the tables from SQL Server, you got the relationships. These 3 tables, I bought it from where? EMP table, DEPT table, and managers table. I bought it from where? I bought it from Excel. Even when you bring it from Excel, you got the relationships here. So how you are getting it is because of this options, right? So first option is import the relationship from data source on first load. First option is import relationship from data source. Data source means from where we are taking the data, we call it as data source. If you are taking the data from Excel, SQL Server is a data source. If you are taking the data from Excel is a data source. What we are trying to tell is, we are telling Power BI, so when you are bringing the tables, so in SQL Server I have tables, like customer table is there, sales table is there, product table is there. What I am telling is, so in SQL Server, it's a relational database, right? In a relational database, tables will store with relationships. We're telling that while you are bringing the customers table, sales table, or product table, not only bring the tables and data, even bring the relationships also. Import relationships, bring the relationships on the first load. For the first time when you are bringing the tables, only that time, bring the relationships. From the second time, so you don't want to bother anything. So clearly, see here, it will first time when you connect to SQL Server, when you bring the tables, it will bring the relationships only for the first time. And if you want to bring the new data, so there is some new customers in the customers table, there is some new sales transactions in the sales table, there is new products in the products table. I want to bring some new data here. When you want to bring some new data, you will refresh. When you refresh, don't do anything. Only for the first time, bring the relationships. That's it. That is this option, guys. So, okay, when it is a database, as database is a relational, it will have relationships, you will get it. So sometimes we'll store the tables in Excel. So in Excel, if you have table 1 and table 2, tell me guys, do you have a relationship between table 1 and table 2 in the Excel? In the file system, will not have any relationships. Then even when it is a file, you are seeing these relationships. You got these 3 tables from file. And which option is working here? There is no doubt first option will not work. First option will work with only relational sources or databases. It will work with only relational sources or databases. So, and when you bring the tables from files, still you are getting the relationship. Second option is helping here. The second option is auto detect new relationships once data is loaded. What Power BI will do is, when you check this option, what Power BI will do is, it will read each and every table in the Power Pivot model. If you load 10 tables, it will read every table in 10 table. Every table it will read. And between any table, if it find a common column, so it will give the relationship. Common name, department number is there, department number is there. When it find a common name, it will establish the relationship. Manager is there, manager is there. When it find a common name, it will establish the relationship. This will read each and every table. Take an example. In the products table, I have a column called ABC column. ABC column. In department table, I have a column called ABC column. Just take an example. The column name is same, ABC, ABC. What the second option will do is, it will give the relationship between these two columns, guys. Even though this product table is coming from SQL Server, even though this DPT table is coming from Excel, when it find the same column name, it will link it. It will link it. Understand, guys? Right? This is the second option, guys. Second option. There is one checkbox which was unchecked. What is that checkbox? We'll see. What is the checkbox? We'll see. In introduction classes, I have not discussed this. In the introduction classes, I discussed about this both. Right? Because of this two, this option will work with all the data sources, all data sources, whether it is database or whether it is files or whether it is some other source. Every data source it will work, guys. If it will read table, it will identify common columns. With common columns, it will give the relationship. That's it. Common column means name. Based on the name, it will give the relationship. The next one is update or delete the relationship when refreshing the data. So update or delete the relationship when refreshing the data. We are not selecting this checkbox. Usually in the real time also, we don't select it. When you select it, what happens? When you don't select it, what happens? I will explain. So initially in the SQL Server, I have customers table, I have sales table, I have products table. Products table. So let me write somewhere here. In the SQL Server, we have three tables like customers table, sales table, and products table. Initially between the three tables, I have the relationship. So initially when I bring the three tables here, I'll get that relationships. I'll get that relationships. Why? Because this option is checked. So when I want to bring the new data into these three tables, I need to go and click on refresh. When I click on refresh, any new data is coming to here, it will come here. Any new data is coming here, it will come here. Any new data is coming here, it will come here. So by default, when you click on refresh, so for some reasons, someone deleted the relationship between customers table and sales table. So first time when I am bringing, I have that relationship. Later on in the source, someone deleted this relationship. When you click on refresh, so still you will have this relationship, guys. When you don't check this, even though second time when I'm refreshing, if someone deleted this relationship, nothing will happen here. Nothing will happen here. Why? Because only I'm asking, bring the relationship only first time. Later on, when you are refreshing, if something is happening, you don't bother about it. We're telling. But if you check this box, guys, if you check this box, what happens is, so it will update or delete the relationship when refreshing the data. So for the second time, when I am refreshing, someone deleted this relationship. When I check this box, when I refresh, it will even delete this relationship. Why? Because we are asking to update or delete the relationship when refreshing the data. Whenever you are refreshing the data to bring the new data to the tables, when there is any changes with these relationships, if you have any new relationship, bring it. Or if someone deleted it, delete it. So never recommended this option, guys. Why? Because The source databases will be maintained by some other team. This database, the place where companies are storing the data, is maintained by some other team. And this OLAP databases will be maintained by Power BI developer. We don't know what kind of changes they will do it in original database. So when you update it, so take an example. For the first time, when I bring sales table and product table, I have the relationship. I created one visual using sales table and product table. I shared that visual with my client. To bring the new data, I click on refresh. Someone deleted this. It will even delete it. When you select this option, it will even delete it. When you even delete it, visual will not show the data. Client will give the complaint. Client will give the complaint that I'm not seeing the data. So you need to cross check what happened. So if you are the one who is maintaining the source database, if you are the one who is maintaining the Power BI database, then going and selecting this option will not harm you. So if someone is maintaining the source database, if you are maintaining Power BI database, whatever the changes they are making, they made here, they will come automatically here. When you check it, it creates a lot of problems to you. So only when you need to check it is when you are the one who is maintaining the source database and you are the one who is maintaining the Power BI database, then go and check this. No problem. You will make the changes here. You are aware of it, what changes you are doing. You will take care. But majority of the cases, this database will be maintained by some other people and Power BI will be maintained by some other people. So this we understand, guys, right? How majority of the data modeling work will be done by Power BI or Power Pivot itself. So in tomorrow is important class. I'll discuss some data warehousing related concepts, guys. Data warehousing concepts. So in this data warehousing concepts, I already shared one video with you. What is dimension column? What is fact column? So go through that video. If you don't know which columns are dimension columns or which columns are fact columns, in a table we'll have columns. Few columns are dimension columns, few columns are fact columns. How we categorize them? Which columns are dimension columns? Which columns are fact columns? Please go through it. So tomorrow's class, there will be a dependency. I already shared one video in the introduction classes, which columns are dimension columns, which columns are fact columns. Please go through that video. Tomorrow is important class. I'll discuss some data warehousing concepts which are related to data modeling part, guys. Fine. I'm done with the class today. Anybody have any questions? Let me publish the note.